Hello everyone, my name's Terry and I'm from Serious Automotive Training. I want to welcome everyone back to another great module of mine dealing with GM Powertrain Performance from Serious Automotive Training. If you want to get a hold of me, seriousautotRaining@yahoo.com. Follow me on LinkedIn or just give me a shout out on YouTube. Today's topic, we're going to continue on with oxygen sensors. So some of the things we're going to talk about today, we're going to talk about the post-oxygen sensor. Previous modules, we talked about the pre-catalytic converter oxygen sensor. Today we'll make reference to the post, so the one in the rear of a catalytic converter. We're going to go over sensor locations. We'll talk about sensor cross counts, and we'll refer back to the sensor range. So we'll review sensor ranges. So today let's start out with our computer-based training. The first thing I want everybody to understand is from GM, the way we identify the location is by the bank. Okay, so let's look here at our computer-based training. Let's look at this bottom one. This would be for an LQ4 engine. Okay, so that's the one that I've referenced here on my plot on the Tech 2. So let's look at the different sensors. So if you look at cylinder number 1 on this V8, bank 1, sensor 1 is where cylinder 1 is. Bank 1, sensor 2 is the downstream one. That would be the post-catalytic converter sensor. So bank 1, sensor 1, cylinder number 1 side. Bank 2, sensor 1 is the opposite side, obviously where cylinder 2 is. And bank 2, sensor 2 is the one in back of the catalytic converter for that bank 2. Okay? So if you're not sure which bank is which, stand at the side of the engine and look what cylinder head is furthest to the front of the vehicle. Okay, very simple. So let's back up here a second and go to our next slide on our computer-based training. And what I want to talk about here for a minute is the big fat term that we're going to be using today is called cross counts. Okay, and I like to call it switch rate. So switch rate, cross counts, it's also called sensor speed, or it could be the fluctuation. Okay, so let's get into this a little bit here. The first thing, let's look back at O2 sensors and talk about sensor range. Okay, 300 millivolts all the way up to about 600 millivolts is the range that we're looking for. Okay. So with the new Diagnostic OBD2 standards, sensors have to have activity, a fluctuation below the 300 and above the 600 in a certain amount of time. So it has to be able to move very quickly. So the way they track that switch rate, you want to look at our screen here, it's going to show you. So this would be a good O2 sensor. 300 millivolts, ramps right up real quick, and switches to rich. If you look at the one here in the red, this is poor, this would be a weak one. So this would set a code, an OBD2 code. The lean is very slow coming up to the rich, so the switching time or sensor speed or fluctuation will be very low. So that's where we get the term cross counts. So when we hear the term cross counts, we're referring to the number of times per second. You could think of it as an AC hertz if you want. The number of times per second, or within a second, that it would switch. Okay? So, number to remember, a brand new sensor is about 50 milliseconds. So it switches back and forth every 50 milliseconds. If it gets slow, it drops out to around 100 milliseconds per swap. That's where it would set the code. Okay, so if it's triggering a slow right here, this may be over 100, this may be 200 milliseconds. So this one may set the code for you. So let's look at the other side of this, the rich to lean here. This is where it's falling back. It's dropping off real quick. It's under 50 millivolts. If it's brand new, it's around 50 milliseconds for that drop. And right here is our rich to lean for the poor one, and you can see how long and lazy and slow that's taken to fall back for this O2. So this would be the pre-O2 sensor feedback. So let's take a look back at our our diagram right here. So this would be a time pattern, okay? If you look at our reference voltage, the 450, this is coming out of the computer to the sensor, okay? Half a volt, 450 is 0.450 volts, or 450 millivolts. If you look at our time, this isn't the O2 sensor signal, this is just a time pattern. So what I'm tracking here is that signal coming out of the O2 sensor, okay, from the 450, it crosses the 300 millivolts, comes back. Now, if you were to measure this in time from lean to rich, this would be the time right here. So that has to be under that switching time from lean, oh, sorry, my bad, wrong color, to here. That has to be with under 100 milliseconds. So let's go back over here. Now we're going to go rich to lean. So we're going to come down here on the rich side. We're going to come to the lean. In between is the time we're measuring. Has to be under with 100 milliseconds. So let's keep going here. So now we're back to lean right here. And now we're rich. I won the Powerball. I'm rich. And we come back down to lean and we're going to measure it here. So you're continually monitoring these. The PCM is continually monitoring the switch time. Has to be within 100 milliseconds. So when we talk about cross counts, we're talking about crossings per second. So the cross count is a term that's used on a scan tool to tell you how many switches per second. And you could use that for diagnostic information when we talk about block learn and interrogator down the road. When we talk in the next one about catalytic converters, we'll get into that. But for right now, I just want everybody to know what cross counts are, what the crossing speed per second, what the sensor speed is. Okay? We call it switch rate. So let's keep tracking here. We'll go back. Let's get into the catalytic diagnostics. And we're going to look at, we're going to talk about post-O2 sensors here for a little bit. And if you don't have a scan tool, you could take your O2 sensor out. I have the 4-wire one here, the heated one that's in the front. But hey, we're just going to use it for reference. So what you need to do, if you're going to use this, make sure if you unplug it and you're going to use your voltmeter, make sure you ground the negative side. The negative side has to be grounded in order for you to get the reading from the positive side. If you can't get in there, hey, leave it plugged in. Use a T-pin on an alligator clip. But again, if you're going to leave it unplugged, you have to ground that negative side so that you could read that voltage drop with your meter that's going to come from the other side. And I'll show you that in a second here. So let's look at our post-O2 sensor. This will be the switching change that we were just referring to here for the time pattern. So there are the switches going back and forth, crossing that reference voltage, that 450. So here's a good catalyst. The top one here is switching back and forth. It's crossing the 600 range and it's crossing the 300 millivolt range. So coming out of the converter, if the converter is working efficiently, you're going to get a nice straight stream across the whole way. And that's going to be on the back side of the O2 sensor. There's a lot of ways you could check this, but hey, the scan tool is the best. So if you want to look at the scan tool that I have here, the bottom one is would be bank 2, sensor 2, the one ramping up. The one on the bottom is the RPM for the engine. The top one is bank 2, and the one ramping around is bank 2 sensor 1. So we're just going to trigger here, and we'll give you a reference of what we're looking at here. Let's just keep going. You can see the RPM. I'm idling. This is a recorded plot on the Tech 2 that I used. So idle speed on the bottom, just rolling through town. Top one, straight across, is the post-O2 sensor. Okay, nice and straight. And then we have the heated O2 sensor jumping back and forth. So it's moving nice. Right across. Beautiful pattern. No code. All right. It's just a plot. using your Tech 2, we could use the data recorder also to record this, and then I could put it up on the screen, which we'll do eventually. Okay, but for today, we're just using a snapshot plot. I plotted 3 graphs: the heated O2 sensor, the post O2 sensor, and the RPM, and I just did it all for bank number 2. So let's go back here and look at the, we want to look at one other thing here for our heated O2 sensor, since we were talking about a few things here. Again, this computer-based training is all available through computer-based CDs. So here we go. Something I just want to refer to here, a great point, and you may want to know this for your ASE test. So if you're going to unplug the connector, so for whatever reason you don't have a scan tool, if you unplug the connector, again, make sure if you're so we're going to check for the reference voltage. We're going to check for the 450 coming out of the PCM, and we're going to check to make sure that that reference voltage is hitting this O2 sensor. So make sure you take this ground side, the O2 sensor low, okay? Now on this one, it's a purple wire. So again, don't use the wires that are in the pigtail, because they're not usually inside. They're letter coded, but they're not, those wire colors that are in here aren't in your schematics. Training material sometimes has it, but so the wire color would be coming out of the connector to the PCM. So we're looking at the purple one. So if you're going to check for voltage coming from your PCM, DC volts on the multimeter, okay? I always like to turn the light on. I take our negative, put it to the battery. The positive is going to go on the low side, so the tan wire. But make sure that the wire coming out of, if you have this unplugged, it has to be grounded. So you're going to ground it with this unplugged, and then you could do your voltage drop. So red wire on the low, white wire, black wire on the battery. So ground it, ground the connector. You could leave it unplugged, and just make sure that that's the way you're going to check that reference voltage. Okay? Easiest way to do it is with jumper wires. Run some jumper wires out of the terminal, and you could go right on here to get your tool in. Very good. So I think that's everything. Let's look at the catalyst diagnostics one more time, just make sure we hit on everything. And I think we did. Yep. So these are just, so from the converter, the sensors would be your rear. This would be the front of the vehicle. Here comes the downpipe coming from the manifold. So the pre would be up on the intake manifold in this particular one. This is the post in the back side of the converter. So a bad catalyst is just going to be almost mirroring the pre. So it's just like having an empty pipe. There's nothing going on inside. It's just mirroring what's going on in the front. And that's why when we drove our Hummer H2 around town, we recorded the snapshot. You could see the RPM is the bottom line. Pre-O2 is the one in the middle, jumping back and forth, and the post is right across the top. So that converter is working well. So again, any questions for me, SeriousAutoTraining@yahoo.com. I just wanted to hit on a couple things today. Make sure you remember switch rate and cross counts. The magic number is 50 milliseconds for a new one. OBD2 sets the code at 100 milliseconds, and that's for the time, the switching time. So again, lean to rich, rich to lean, the time's measured, and this is how we get our cross counts, our fluctuations. So again, we went over the post O2 sensor, showed you the graphs, went over sensor locations, cross counts, we talked about the range. Hey, have a wonderful weekend. My name's Terry, and see you again at the next module. Thank you.